Okay. All right, so we're going to do 9.2. Well, this is 9.1 still, right? And we called yesterday's notes B or A. Just call these A then. All right, so this is circles. Okay, so a circle is a set of points in a plane at a given distance, which is the radius, and from a given point, which is the center. Okay, so just like yesterday, we're going to draw a picture, we're going to label some stuff. Circles are much quicker. So a circle has a center and a radius. Let's just put the center here. We'll label it C. Okay, then it has some radius R. So this radius is the same no matter where you hit the circle, right? So I'm going to attempt to draw a circle here. Circle-ish. Okay, so no matter where you draw that radius, it'll be the same length, right? Because it's the same distance. So the center we represent as HK. And our radius we'll label as R. Okay, and now we have the standard form. So it's x minus h squared plus y minus k squared equals r squared. I'll give you these after. Okay. Okay, so that's really all the information for a circle, right? The circles are the easiest ones. So we're just going to do some examples now, all right? So we'll call this example 1. Is everybody ready for me to move on? I went back and watched one of the videos. I kind of talk fast sometimes, you guys. I didn't really realize how quick it was. You should tell me to slow down if I'm going too fast, okay? You really should, because wow. All right, but today I'm not going to go fast. Okay, so we're going to be given the center at -4, 1, and a point on the circle is going to be -1, 3. Okay, we're going to write the equation. So anytime we're writing an equation of any of these conic sections, we have to put them in standard form. Okay, so we're going for this, right? We know the center, so we know H and K. What is this point? What does that represent? Like this is H and K, right? This is a solution, right? Because it lies on the circle. So if it's a solution point, then what are these? X and Y, right? So I have X, Y, H, and K. Well, doesn't that minimize my variable down to R? Which is really the only other piece I'm missing, right? Because I need the center and I need the radius. So I need to find the radius. In order to do that, I'm going to plug in all this information. So I'm going to have -1 minus a -4 squared plus 3 minus 1 squared equals r squared. Right? I'm just plugging in my x and y, h and k. So now this is going to give me, let's see, 3 squared, so 9, and 2 squared, 4. So 13 is equal to r squared. Now, do I have to find r? Like, do I have to take the time to take the square root here? No, because think about the standard form. Isn't it just r squared? So once you're here, you're done. Now, if this question would have said, what's the radius, then what is the radius? Square root of 13. Okay, but you don't need to find that right now. So we're going to go back. We're going to plug in just our center and our radius, and we'll be done. So x plus 4 squared plus y minus 1 squared equals 13. No, because r squared is already 13. Okay? So like if we knew r was the square root of 13, then when you plug it in, you'd have to square it. Okay? Okay, that was pretty easy, right? Too easy. So let's make it a little bit more difficult. All right, given 4x squared plus 4y squared plus 4x minus 8y minus 11 equals 0. Write the equation in standard form. And find the center and radius. This looks a little different. We got lots of terms going on here. Yesterday, when you guys were doing parabolas, did you recognize that it was a parabola when it was given like this, like all together? Could you recognize that? Because why? It had only one squared term, right? So when you have an equation that has only one squared term, it has to be a parabola, right? That's easy to see. A circle is just as easy to see, actually. So for a circle, you have to have two squared terms. And they have to have the same coefficient in front of those squared terms. So look here, I have a positive 4 and a positive 4, and I have an x squared and a y squared. Right now, you should be able to recognize, without me telling you, that this is a circle because of that. Do you understand? Same coefficients, both squared terms. Okay? So now, in order to get this into standard form, what do you think I have to do? What did you have to do yesterday when it was given like this? You had to complete the square. So the nice thing with circles is that you don't get to just complete the square one time. You get to do it twice. It's like a 2-for-1 special. And that's true for an ellipse, a hyperbola, and a circle. Okay? But it's so easy now because we're experts at it. All right? So it's not a big deal. So the first thing you're going to do is you're going to like reorder all your terms. So you want your x's together, your y's together, and then we want to move the constant to the right side. Okay, so that's what I'm going to do first. So I'm going to have 4x squared plus 4x plus 4y squared minus 8y, and then I'm going to move the 11 to the right. Okay, so now the goal is to complete the square. So the very first thing we had to do was we had to get a coefficient of 1 in front of our squared term, correct? So what I want you to do right now is just ignore all of this and only look at that 4x squared plus 4x. If I want to complete the square on this piece, what do I have to do? Take out a 4. Factor out that 4. Everybody agree with that? Because I have to get a coefficient of 1 right here. So I'm going to take out this 4. That's going to leave me with x squared plus x. And I'm going to leave a space. Okay. Now we're going to ignore all of the x's, and we're only going to look at the y's. If I want to complete the square on this piece, what do I have to do? Factor out a 4 again, right? Because I want a coefficient of 1. So I'm going to factor out this 4, leaving me with y squared minus 2y. I'm going to leave a space, equals 11. I'm completing the square twice simultaneously, okay? So now I'm going to do the same thing again. I'm going to ignore all the y stuff, and I'm going to only look at the x. If I'm going to complete the square here, what do I have to do? I have to take half of that 1, so 1/2. So I'm going to add this 1/2 squared here. Okay, so now we got to think. I got to uncover some of this. We're still ignoring the y. Inside here, I'm adding a 4th, right? Because when you square a half, you get a 4th. And if I multiply it by 4, aren't I adding a 1? So if I add a 1 here on the left side of the equation, then I have to add a 1 here on the right side of the equation. Okay, so that takes care of the x piece. Now let's look at the y piece. Half of -2 is going to be a -1 squared. So I'm adding a 1 on the inside. But I have to multiply it by the 4. So I'm really adding a 4. If I add a 4 on the left side of the equation, then I have to add a 4 on the right side of the equation because that's the only way to keep this all balanced. Okay, now we're going to move into the factoring part. So now we factor. I have x plus 1/2 squared here, and I have y minus 1 squared here, equals 16 when I combine all those. This is a circle, okay, so we see those matching coefficients here. I'm going to divide by 4, because if you go back to the standard form, there's no coefficients in front of the squared terms, right, these squared factors. It's gone, it's just 1, so I have to get the coefficient of 1. In order to do that, I can just divide by 4. Okay, so I divide this side by 4 and this side by 4, and I end up with x plus 1/2 squared plus y minus 1 squared equals 4. Okay, so there's my standard form. That part's done. What's the center? Remember, it's the opposite of what you see, right? So if this is a positive, then my center should be at negative 1/2 comma 1. And what's the radius? 2, because it's got to be the square root of this 4, right? Because this r squared is 4. So you got to take the square root, so r is 2. And this is what they wanted us to find. How are we doing? Okay? Not bad, right? Like, it seems scary because you got to complete the square twice, but it's really not that bad. All right. Here is something new. The distance formula. From a point to a line. Okay, so that's what we're going to do right now. So we know the distance formula, like if you're given 2 points, right? Square root x1 minus x2 squared plus y1 minus y2 squared, right? We know that. You've been learning that forever. Well, there's another distance formula, and this distance formula is used when you have a point and the equation of a line. Okay, so that's going to come in handy for us. So if you're given, x and y, so this point, and a line, so like ax plus by plus c equals 0, right? If it's just in general form. Okay, then you're going to use this formula. So the formula is the distance equals the absolute value of ax plus by plus c over the square root of a squared plus b squared. I will tell you that in this chapter there is a ton to memorize. Okay, so add this to your list. You have to know this. All right. So this is, if you're given a line and the point, you can find the distance between those. Okay, instead of given 2 points. All right, so we're going to do an example with that now. I'm going to leave it up. Yep. Okay, so let's try an example with this. This is going to be example 3. All right, given a circle with a center at negative 1, 3, and 2x minus y equals 1 is tangent to the circle. Write the equation of the circle. Okay, so I'm gonna draw a picture because this is helpful. All right. So let's say, right, I have this circle, and I'm at negative 1, 3 for a center. Okay, so here's the center of the circle. I also know that I have this line and that it's tangent to the circle. You got to go back in your mind to geometry. Okay, what does it mean to be tangent to something? If the line is tangent to the circle, what does that mean? It only touches it at one point, okay? So you need to remember that. Also, there's a few ways to manipulate this line. Think about 2x minus y equals 1. Isn't that the same as y equals 2x minus 1, like in slope-intercept form, right? If you just manipulate it. So doesn't that mean you have a y-intercept at -1 and then the slope is 2, so up 2 over 1, right? So here you have this line, and this is the line y equals 2x minus 1. And then you have this circle. So the circle has to only touch at one point. So, I don't know, I don't know where it touches, but let's just pretend it touches right there. Okay, so there's the point that it's tangent. That's clearly a circle. Okay? Ish. Okay, so this is the radius. Now let's think about this. In order to write the equation as a circle, you need to know two things. You need to know the center, and you need to know the radius. But all I know is the center. So far I know x plus 1 squared plus y minus 3 squared equals r squared. Okay, now like previously, I was given a point on the circle. So I could just plug it in, I could plug in the x and y, I could solve for r. But I'm not given that here. Here I'm given a line and a point. So do you see why that new distance formula is going to come in handy for us? Because can I find the distance from that point to the line which represents the radius that I need? Okay, so that's why you have to use that formula. Does everyone see why? Yes? Yes, because remember that that distance formula measures the distance from a point to a line. Well, the point is the center of the circle. The line is going to also include that point that touches the circle. And those points, the distance between those points, is the radius. Okay? So now what I need to know is what is A, B, C, and X and Y. Okay? So in order to find A, B, and C, you're going to want to put this line into general form. So I'm going to manipulate it again so that it looks like 2x minus y minus 1 equals 0. So doesn't that mean that A equals 2, B equals -1, and C equals -1? Right? Just pull those coefficients. What's my x and y? It's got to be the center point. It's got to be the point that you were given. So this is x and this is y. So now I know x is -1 and y is 3. Now the equation says that the distance equals the absolute value of ax plus by plus c divided by the square root of a squared plus b squared. So now I know all those pieces. All I have to do is plug it into the formula. So I have 2 times -1 plus -1 times 3 plus a -1 over the square root of 2 squared plus a -1 squared. Right? You're just plugging in the pieces and then you're going to simplify it. So let's see, we get a -2 plus a -3 plus a -1. So -6 over 4 plus 1 is 5. So square root of 5. So this is going to be 6 over the square root of 5. Now, normally, the first thing we would do with this is start rationalizing, right? But keep in mind that this distance is really the what? The radius. Well, what happens when you plug in the radius to this formula? You square it. So that square root on the bottom is going to go away anyway. So don't bother rationalizing anything until you plug it in and see what it really does. So, final answer should be x plus 1 squared plus y minus 3 squared equals 36 over 5. Okay, take all that in for a second. Yeah. Yeah, tons of it. Are there any questions on this example? This was kind of a lot, right? Lots of thinking there. Right, everybody see? You got to know this formula, so you have to memorize it. We have one more example. Can I move this? Okay. Example 4. Okay, write the equation of the line tangent to x minus 3 squared plus y plus 1 squared equals 10 at the point 6, negative 2. Okay, so we're going to do lots of thinking again. We're going to get a picture, and we're going to think about what does all this mean, and what am I even looking for? So, first of all, I have a circle, okay, and the center is at 3, negative 1, and the radius is the square root of 10. Do you agree with that? Everyone recognize that from the circle. Standard equation is given. Okay, so 3, negative 1 is like here, and then I'm going to wait on drawing the circle until I plot my other information. So now they also give me this point, 6, negative 2. So I'm going to go ahead and plot that point as well. Okay, now it says, write the equation of the line this time. So this time I'm looking for an equation of the line that's tangent to the circle at this point. So doesn't that mean that there's a line that goes through this point right here, and then there is a circle that touches it at that only that one point, because that's what it means to be tangent to the circle. So here's the line, and here's my circle. Okay, now I know that the center is at 3, negative 1. I also know that this radius is the square root of 10. So the distance from the center to the line is the square root of 10. I also know that this point is 6, negative 2. Can you see all of that? Can you understand all of that? Are there questions? Okay, so I'm trying to write the equation of the line. So I am looking for y equals mx plus b. Okay, that's my goal. I don't know the slope. I don't know the y-intercept, so I know nothing. Except I do know x and y, right? I have a solution point on the line. So that's a good start. You have to remember something else about the line that's tangent to a circle. Jake? It sure is. So this radius has to be perpendicular to that line. Okay, that's the definition of a line that's tangent. Okay, it touches at only one point and it's perpendicular. Okay, to the radius. Okay, so now that's good. This is good information to know. How does that help? We're gonna go way back. Like we're going like 8th grade math back. Okay. So it's like a trip down memory lane here. Mouth.
You find the slope of the root 10 line,
yeah,
and then make it perpendicular to get the slope of the other one.
That's exactly right. So if you were to find the slope of the radius, then isn't this slope just the opposite reciprocal because they're perpendicular? Remember all that stuff? Yeah, from linear algebra? Yeah, good stuff. Okay, so we're going to find the slope. You remember how to find the slope, I hope. Yeah, y2 minus y1 over x2 minus x1. So I'm going to find the slope of the radius. So that's what I'm looking for first. So I'm going to have negative 2 minus this negative 1 over 6 minus 3. So that's going to give me negative 1 over 3. So the slope of the radius is negative 1 over 3. That means that the slope of this line is what? Just 3, right? Opposite reciprocal, so flip it, change the sign. In order to be perpendicular, you have to have opposite reciprocal slopes. So now I know y equals 3x plus b. But we also talked about the fact that this is x and y. It's a solution point of the line. So can't you just plug that in to find b? Agree? So I'm going to have negative 2 equals 3 times 6 plus b. So b is negative 20. So our equation of the line is y equals 3x minus 20. Questions?